Hello, my Algebra 2 students. We are looking at finding equations of exponential functions today. Since exponential functions grow by a constant multiplier, we say they're somewhat analogous to geometric sequences. So when we did sequences in series, you'd always multiply by a constant value to get from one term to the next. And what we mean by that, is if we take this first function, so if I go in here and I do 3 and then times 4 raised to the x power here, and I go, let me quick switch that, there we go, and I go to my table, right? At 1, it's 12, and at 2, it's 48, and at 3, it's 192, and so on, right? So what we're seeing here, right, is to get from 12 to 48, you have to multiply by 4. And then if we go 48 times 4, there's 192, and so on. So a geometric series, that was called the R value or the common ratio. And so the R value here would have been 4 itself. But that was for when we were talking about the formula of A of n equaling A sub 1 times R to the n minus 1. So it's been a little while since we've done that. Probably good to bring it back up. We'll have a final at some point. But for now, it's just saying that it mimics the same type of pattern here. So when it says we can use this to help us find the equations that we need. So when you think about what was going on in the last one, that made 3 the first term, and then 4 the constant multiplier. So with this, take a look at the example you have here. It's saying for this given x value, here's your y value. So at 0, it's 5, at 1, it's 15, and so on. So if I look, what am I multiplying by to go from one term to the next? Well, hopefully we're seeing times 3. 15 times 3 would be 45, and we can double check it. 45 times 3, yep, there's that 135 right there. And so if the common multiplier, or the R value, is 3, that is the same, as when we look at this here as like the B value. That means the B value, or the base, would be 3 here. And then where are we starting? Well, the first term was 5. And so that's for A sub 1. In this case, the first term here would just be plain old, A equals 5. So based on that, the equation in A times B to the x power form, because I'm looking at it right here, that would then be 5 and then times 3 to the x power. So let's test it out and see if we're right. So if I go up here and make this 5 and then times 3 to the x power. All right, so at 0, it's 5. At 1, it's 15. 2, it's 45, and so on. So we did it. All right. Now it says determine a recursive equation with the same function. Now we're really digging back into our sequences and series. So recursive equation meant you had to tell me what's the first term and then how to get to the nth term. So if we play that game, the first term here would have been the 5. And then to get from there, you would have to take 5, and multiply by 3. Well, how do I say that generically? I would have to take the first term, or I should say the term before this one, which was A sub n minus 1, and then multiply it by 3. That would be it in recursive terms. All right, that's enough about sequences and series. Let's move on to talk about just exponential functions. When you flip on over here, it says, all right, well, finding the equation becomes more challenging if we don't have, all the output values. Maybe we only have a couple of them. So when it says, let's start with a basic, that's this guy right here. So for a function that's going to be in this form, so in this general exponential function form, we know f of 0 equals 8 and f of 3 equals 1,000. What we can do is we can actually set up a little equation to solve. So let's start with f of 0 equaling 8. What that literally means is that for x being equal to 0, the y value will be 8 itself. So let's take this generic form right here, and if we do f of 0, it'll be a times b to the 0 power, because that's what f of 0 is, we're saying should be equal to 8. All right, well, what happens when you raise something to the 0 power? B to the 0 just becomes 1. So I get a times 1 equals 8, or just a equals 8 right there. All right, that worked out pretty nicely. And then to be able to figure out the b value, we have more information here. But first things first, that means at this point, we know f of x is equal to 8 times b to the x power. Now let's plug in what we know. When we put a 3 in for x, the y value will be equal to 1,000. So when we put a 3 in here, which means a 3 in here, this whole thing will come out equal to 1,000. Well, we can solve. To get b by itself, let's divide by 8 first. So b cubed, grab my calculator here, 1,000 divided by 8. Oops, just kidding. 1,000 divided by 8. There we go. 125. And then to undo b cubed, we can take the cube root. If you don't happen to recognize that one, use the math key on your calculator. So if I go to math and then cube root 125, that comes out to be 5. And so what that means, when it says find the equation is now a, so 8 times b, 5 to the x power. And it's super easy to check. Just use your graphing calculator. So if I now plug that into my y equals 8 times 5 and then raise it to the x power, go check the table. Are those points on there? So there's the 0.08 right there. And then if I come down, there's the 0.3 1,000. So we're good to go. So it's a nice little way to check and see if you're correct. Now it does say here, it's easy to do those algebraically when you're given the y-intercept, because that's what 0, 8 is the y-intercept itself. It's a little trickier when the 2 points don't include 0, a. So in that case, when we don't know that value, a fast way to do it on the calculator is to actually do an exponential regression. Now, there are other algebraic ways to do it, but this is the easiest way, and it works out really nice. So if we take the last example that we just did, the points that we have, if we have f of 0 equals 8, that's the 0.08. F of 3 equals 1,000 literally means the 0.3 1,000, which means we can write it in our table of values as 0, 8, and then 3, 1,000, just like that. So into my calculator, I can put this into my lists. Now, I already set something in my list, so I'm going to make this list 3 and list 4. You can use list 1 and list 2. You choose. But if you're going to watch with me, then I'm going to go to Stat and then Edit. I'm going to go over to list 3 and make this 0 and 3. Into list 4, I'm going to make it 8 and then 1,000. So there's my coordinate points. Now you can follow these steps here. Stat, calculate exponential regression. So stat, go over to calculate. I'm going to go up because it's a little faster. It's choice 0 there, exponential regression. Now, mind you, my default on the calculator is for list 1 and list 2. I put mine in list 3 and list 4, so I do have to change that. If yours are in list 1 and list 2, then you're ready to go. All right, and then look what it gives you. Is it tells you y equals a times b raised to the x power. A equals 8, b equals 5. And then don't worry about the r values. It kind of speaks to the accuracy, but you don't have to worry too much there. So this really means that we have 8 times 5 to the x, which exactly matches what we got right there. All right. Now, the nice thing is you can use this shortcut for every future question. So for number 4, when it says an exponential function exists such that here's a couple values that we know, which of the following has to be the value of the base? All right, well, I'm going to run the regression, and it's going to tell me the full equation. I just have to answer it for the base part of it. So here's what we need to do. X and Y. So the 0.43 is the first point. 648 is the second point. And then again, list 1 and list 2 Or in my case, I'm going to go list 3 and list 4. So I'm going to go right back to my calculator, stat, and then edit. And into list 3 and list 4, I'm going to type in my new points. So 4, 6 into the first column, 348 into the second column. And then we're going to try it one more time. So stat, calculate, and exp reg is an exponential regression right there. I'm already set to list 3 and list 4, so I can hit enter. And now it gives me y equals a times b to the x, where a is this 0.011 and it keeps going. But this question asked about the base, and that's just the b value. So the base comes out nicely to be 4. And there we go. All right, we're going to save number 5 for a little recap for class. When you're ready, flip it on over. We are also, going to save number 6 for a little recap. Let's talk about number 7, and then we will set ourselves up for number 8. So for 7, it says you have a bacterial colony is growing at an exponential rate. It is known that after 4 hours, the population is 98. After 9 hours, there's 189 bacteria. Determine the equation that models it. Is the population is y, and the number of hours is x. At what percent rate did the population grow per hour? Or at what rate is it growing per hour? All right. We can set this up for a calculator. Remember, x is the number of hours. Y is the population. So when it says after 4 hours, the population is 98. After 9 hours, the population is up to 189. We can let the calculator do the work to start. So into your list, stat and edit, we have 4 and then 9. Into the second list, 98 and then 189. All right, third time through should be a charm. Stat, calculate, exponential regression. And then I come out with y equals, it didn't tell us where to round because it's only our notes. So let's just take it a couple decimal places. Maybe 948 and then 1.14 raised to the x power. In the case of this, when it says what percent rate is it growing, this value right here, if it's over 1, that's how I know it's growth. And 1.14 is equal to 1 plus whatever rate that it's going up by. And so what that means is if the rate is 0.14, then really I can multiply this by 100, and the rate is going to be approximately 14%. We'll do more with that later. All right, what I would like you guys to do is for example 8. This one is giving you box office revenue from one of the top movies of 2013. Here's the number of weeks that it's been out. Here's the revenue. That is going to need to go into list 1 and list 2 in your calculator. And then it says create an appropriate exponential model. So that's code for you're going to do an exponential regression. And it asks you to round it to the nearest thousandth. So that's going to be 3 decimal places. And then it says predict the revenue during week 11. I want you to try this question and see if you can answer it. It's part of the post video question.